Hi guys, you're welcome to my channel. Today we want to start the concept of calculus from the very basic part of it. In our previous classes, we've talked about different functions that we need to have knowledge about them before we go into calculus. And if you want to look into those functions that we talk about, the transcendental functions and the polynomial functions, you can check the description part of this video to access this lecture. Now, today we want to look at limits of a function. I'm going to be taking it from the very basic part to a kind of complex level before we call it a day today. So I want you to pay maximum attention to this very basic part of it. If you understand this, then differentiation and integration become so easy for you. However, there's a lot to learn under limits, and we shall do that together. So let's get started. Now, when you talk about limits of a function, it's very easy for you to convince a limit of a function with function itself. That is how we tackle functions. For example, if I give you that f of x is equal to x squared plus 2x plus 1, and I ask you to look for f of 2. So f of 2 is going to be 2 squared plus 2 into 2 plus 1. And this is 4 plus 4 plus 1, and that is 9. So that means f of 2 equal to 9. The same thing is, if the question says find the limit of x squared plus 2x plus 1 as x tends to 2. All the same thing is just for you to say, okay, as x tends to 2, this becomes 2 squared plus 2 into 2 plus 1. And that will be 4 plus 4 plus 1. That will give us 9. Simple, right? Yeah, it's quite simple. But this is not always the case. You have it to be directly like this because this given function is continuous at any point. If you are given a function that discontinues at a particular point, you might need a deep knowledge of limit for you to be able to tackle such a question. Now, for us to understand what I'm talking about, let's look at this particular function here. If I'm given that the limit of x squared minus 1 all over x minus 1 as x tends to 1. If I'm given this limit and I'm given this same function f of x squared minus 1 divided by x minus 1. So if I say find f of 1, if you do that, you are going to find 1 squared minus 1 divided by 1 minus 1, and that will be 0 over 0, what we refer to as undefined. Now, if we do the same thing with the limit, we are going to have this same thing. However, we are not supposed to have this same result if we are to take the limit of this given function. Why? The reason is because when you talk about limit is not an absolute value of x. Limit is just the point at which x is tending to. For you to get what I'm saying, let's pick some random value for x closer to 1. For example, if I say 1.01, 1.01 is very much closer to 1. 1.001 is much closer to 1. I see it now. So if I have these values, let's test this with this limit. So if I put 0.01 into this function, so I have 1.01 rather, 1.01 squared minus 1 divided by 1.01 minus 1. So if I do this, I have to square 1.01 all square. So that will give me 1.02 minus 1 divided by, this will give me 0.01. So if this is what I have, then that means this is 0.02 divided by 0.01. So when you say 0.02 divided by 0.01, that should give us 2, right? 0.02 divided by 0.01, so that will give us 2. That means the result I have here is 2. Also, if I try this particular value, I will have a value closer to 2 as well. So what does this mean is that as x is approaching 1, the value of this function is approaching what? 2. So whenever what a question is given to you under limit that x approach a certain value, just know that that value is not an exact value, it's just what? A value that x is tending to. Are you getting it now? So we are now told that if x is tending to that particular value, then what will the function tend to? That's exactly what they ask us to do when they talk about limit. Now, let's see how can we then solve this particular question successfully. So if you are given that limit of x squared minus 1 divided by x minus 1 as x tends to 1, what we need to do is to try as much as possible to get rid of the denominator. Because what really makes this function be undefined is as a result of the denominator that equal to 0. So in order for us to avoid that, we need to try to cancel the denominator. And that might make us to want to do some kind of factorization. So this implies that the limit as x tends to 1, remember x squared minus 1 is the difference of 2 squared. We can write it as x plus 1 into bracket x minus 1 divided by x minus 1. So if I have this now, you get to see that this and this can cancel. So if I cancel these two, I have that the limit as x tends to 1 of x plus 1. There's nothing much I can do here again. That is, this is the best I can do to reduce what? The functions. Now, what's the next thing to do? The next thing to do is to plug in the value of x into this function. Then we see the value we are going to have. So when you plug the value of x here, you therefore have 1 plus 1 to equal to 2. And that's to tell you that the limit of x squared minus 1 divided by x minus 1 as x tends to 1 is equal to 2. Do you see how we solve this now? Good. But not all questions will just come as easy as this. However, let's consider more questions under this. And we want to solve enough example in order for us to understand this concept of limit very well. So as I will be dropping the examples, pause the video, give it a try and continue watching. That's the best way to learn mathematics or physics. So let's try this example. Find the limit of x squared minus 4 divided by x minus 2 as x tends to 2. So you can pause the video now and give it a try. So with this now, I can rewrite this function because if I plug in 2 directly into this given function, I'm going to have it to be 0 over 0. But that is not what we are looking for. So I have to simplify this given function by saying the limit of x squared minus 2 squared divided by x minus 2 as x tends to 2. So I'll write this as the limit as x tends to 2 of into brackets x plus 2 and x minus 2, since this is difference of 2 squared, divided by x minus 2. So if I have this and this can frizzle out. Then I have the limit as x tends to 2 of x plus 2. So this equal to, put the value of 2, so we have 2 plus 2, and then the limit of x squared minus 4 divided by x minus 2 as x tends to 2 is therefore equal to 4. I hope you understand this now. Alright, so let's move a bit upward in this same format. So like I said, we are going to look into enough example under this limit of a function so that you get to understand it better. So if I have that evaluate the limit of x cubed minus 27 divided by x minus 3 as x tends to 3. So we are asked to evaluate this given function here. But before you can go on with this, I have a lecture on algebraic identity. Algebraic identity will help you a lot when you are handling limits of a function. And I'm going to drop the link in the comment section, in the description part of the video, so that you can master some identity that can help you navigate the concept of limits. Now, if I have this, there's something we call difference of 2 cube. That is, if I have a cube minus b cube. We are all familiar with difference of 2 square. Of course, we've used them currently now. So let's try difference of 2 cube. So this is the same thing as saying a minus b into bracket a square plus ab plus b square. So this is difference of 2 cube because we are going to be needing it for this particular question. So let's go on. So this question can be written as the limits of x cubed minus 3 cubed divided by x minus 3, then x tends to 3. So we write this as limit of x minus 3 into bracket x square minus plus 3x then plus 9, because 3 square is going to give us 9 as x tends to 3. Everything divided by x minus 3. So if I have this, that means this and this can cancel. So we have that the limit of x as it tends to 3 of x square plus 3x plus 9. So put the value of 3 there. We have 3 square plus 3 into 3 plus 9. And that will give us 9 plus 9 plus 9. And that is 27. So that means the limits are as the limit of x cubed minus 27 divided by x minus 3 as x tends to 3 is equal to 27. As simple as that. So let's look at another question. All right. So if we go a bit complex into some kind of rational functions, like find the limits, evaluate the limits as x tends to 3 of 1 over x minus 1 over 3 divided by x minus 3. Now, if you look at this, anytime you have a function like this, the first thing you want to do is to reduce this fraction to the very smallest version of it. That is, make it less complex. So how do we do that? We look for the LCM of x and 3. And when you look at that, you get to see that it's 3x. So what we do is to multiply both numerator and denominator by 3x. So let's do that by saying the limit as x tends to 3 of 1 over x minus 1 over 3 divided by x minus 3. So we'll multiply it by 3x over 3x. So if we do this right now, we are going to have that the limit 3x times this will give us 3 minus 3x times this will give us x divided by 3x into bracket x minus 3. Don't bother to open the bracket, because if you try open the bracket with 3x, then you might be just parabolating. I get where I'm coming from. That would be an unnecessary repetition. Now, how do we go on now? We want to try to cancel what we have at the numerator. But if you look at what we have at the numerator and what we have at the denominator, you get to see that this is 3 minus x and this is x minus 3. So how do we go about it? Very simple. We can just say limit as x tends to 3, factorize out or multiply this with minus, that is a negative sign. So I have this to be negative x minus 3. Sorry. If I multiply, that is, I want this one above here to look like the one below here. So all I need to do is to multiply both numerator and denominator by negative x. So if I multiply both numerator and denominator by negative x, that will make it easier for me to work with. That is, I'll be having negative x times negative. That will give me x, and this will be minus 3 divided by negative 3x into bracket x minus 3. I hope you understand this. Yeah, I almost get it wrong there. So this and this would cancel. So if this and this cancel, I have this to be the limit as x tends to 3 of 1 divided by negative 3x. I hope you get this right. All right, so if this should be the case, we have reduced this very much better. So we can input the value of x into this. So we have 1 divided by negative 3 into 3. And that will give us that the limit of 1 over x minus 1 over 3 divided by x minus 3 as x tends to 3 to equal to negative 1 over 9. So this is negative 1 over 9. I hope you understand this now. So basically, this is how to tackle this kind of a question. So let's look at more complex questions, but in form of radical now. So we're looking at a similar question, but in form of radical. So let's say I have evaluate. The question says evaluate evaluate 1 divided by root x, 1 divided by root x minus 1 over 2 divided by x minus 4. So this is the limit as x tends to 4. So we have the limit as x tends to 4. Obviously, by the time you put the value of 4 into this question, it's going to be undefined, right? So we try to look for the LCM of this. So let's find the LCM first. So when we get the LCM, then we can now find the conjugate, because whenever you're having a radical like this, what is best for you is to multiply by the conjugate of the radical. So let's see how we can go about that. So we say the limit as x tends to 4 of 1 over root x minus 1 over 2 divided by x minus 4. So if this is what I have, then I'll multiply both numerator and denominator by 2 root x. So if I multiply by 2 root x, I will have that the limit as x tends to 4 to be root x minus, so this 2 is going to cancel this, sorry, it's supposed to be 2, not root x. So that will be 2 minus root x divided by 2 root x into bracket x minus 4. So this is exactly what I'm going to have right now. So if I have this, I can continue by saying the limit as x tends to 4 of 2 minus root x divided by 2 root x into bracket x minus 4. So how do we go about this? The next thing we want to do right now is to multiply both numerator and denominator by the conjugate of the numerator. So whenever you're having a radical like this, you multiply by the conjugate. Very, very important that you understand this, and you should not forget it. So I'm thinking of doing something before multiplying with the conjugate. However, I think I should just multiply with the conjugates and move on. So I'm going to be having this. So this is 2 minus root x divided by 2 root x into bracket x minus 4. So let's multiply by the conjugate. That's 2 plus root x divided by 2 plus root x. So if I have this, I have the limit as x tends to 4 of 2 times 2, that's 4, and the root x times root x, that's negative x. Then I have 2 root x multiplied by this. That will give us 4 root x, then plus 2 root x multiplied by this. That will give us 2x. I hope you understand that, because whenever root x multiply root x, your result is going to be x. So everything multiplied by x minus 4. So let's extend this division line. Right. Now, this is supposed to cancel this directly, but if you look at this, we have this case before. So we have to do the same thing that we do then. The same thing is what we are going to do right now. So we have that the limit as x tends to 4 of x minus 4 divided by negative into bracket 4 root x plus 2x into bracket x minus 4. So we have this to cancel this. And then our result is equal to the limit as x tends to 4 of negative 1. So I'm taking this negative up, just like I multiply both numerator and denominator by negative 1 again. Are we together now? So whatever you do to the numerator, if you do it to the denominator, the fraction remains the same. So I have 4 root x plus 2x. Then I can input the value of x now, because I already reduced the fraction to the barest minimum. So I'm going to have that the limit as x tends to 4 is equal to negative 1 all over, the limit as x tends to 4 of negative 1 divided by 4 root x plus 2x is equal to negative 1 divided by 4 root 4 plus 2 into 4. And that will give us negative 1 divided by root 4 times root 4, that's going to give us 8, plus 2 times 4, that's also 8. Then our result is negative 1 over 16. I hope you understand this. Now, to wrap up the aspect of radical, let's look at these questions. Then we'll move on to checking if a limit exists or not. Because it's possible that a limit would not exist no matter how much you simplify it. So let's look into this last question on the radical before we consider that. So the question says, evaluate the limit as x tends to 9 of the square root of x minus 3 divided by x minus 9. So if we have this now, how do we go about it? Remember, we once said it before that once you have a radical, you always multiply by the conjugate of the radical in order for it to continue. So we do what? We multiply by the conjugate of root x minus 3, and that is root x plus 3. So we use that to multiply both numerator and denominator. All right, so we'll find the limit as x tends to 9 of this. So this is going to be root x times root x, that will give us x, and 3 times 3, that will give us negative 9, because it's difference of 2 squared. There's no point in you trying to expand the bracket. It's going to be unnecessary repetition. I hope we get that. So right here now, let's just put this as x minus 9 into bracket root x plus 3. There's no point trying to expand the bracket because it's going to be unnecessary repetition. Of course, we'll see where we are going. So this and this cancelled. Then you have that the limit as x tends to 9 of 1 divided by the square root of 3 plus 3. That will give us 1 divided by the square root of 9 plus 3, and that will be 1 over 6. I hope we got this now. So this limit of root x minus 3 divided by x minus 9 is absolutely 1 over 6. Now that we have understand the concept of limit, now let's go to a case whereby a limit did not exist. How do we know if a limit exists or not? For you to know if a limit exists or not is usually in two ways, or more than two ways, but obviously as a JAMBite or a WAEC student, you will not be asked to use the graphical method to solve limit because it's not meant for your level. But if you are an A-level student, you might want to consider to understand the graphical method of solving limit. For that reason, this video is specifically for the JAMBite. So I'm going to be skipping the graphical part of it. However, if you want to know it, you can let me know in the comment section. Now, let's say you are given a limit of x tends to 3. The limit as x tends to 3 of x minus 3 all squared. And you are asked to find this limit. You know, if I put the value of 3 into this function, what I'm going to be having is obviously undefined, right? But I cannot conclude that it is undefined. However, I still cannot simplify further because I have just 1 divided by x minus 3. So I really do not know what to do except if I want to go into the complex aspect of mathematics by thinking of how to rewrite this particular one, in a way whereby I'll be able to cancel this one out. That is, write something that is going to be 1, but look in this particular format. I don't know, maybe you understand where I'm coming from. Let me give you a very quick example. If I have 0, how else can I write 0? If I have 0 over 0, I can write 0 over 0 as 100 minus 100 divided by 100 minus 100. You see this? And I can make some other sense from this by saying 10 minus 10 divided by this can be 10 square minus 10 square. Can you see how I rewrite what? 0 now? Obviously, I'm going to be doing something nonsense here that is not mathematically correct. But just for the sake of example, that is why I go into this direction. So I don't want to think like that. So the first thing I want to do before I start thinking in this direction is to check if the limit actually exists. Are you getting where I'm coming from now? So if the limit exists, I can now start thinking mathematically that, okay, let me try this or try that. But before then, I need to check if the limit actually does exist. So if you look at this now, by the time I slot in the value of 3 into this question, I'm going to be having 1 all over 0 squared, right? And 1 over 0 is absolutely infinity. But since this one is positive, why do I have infinity as my result here? I'll be having infinity as my result because when your denominator is very small, the number tends to be very, very large. That is, the result of the fraction tends to be very, very large. So if your denominator is as small as nothing, like 0, then that means the value of the fraction will be very, very large, and that's what? Infinite, right? So infinity can be an answer, right? That is, it can be an answer for a particular limit. Are you getting where I'm coming from right now? But we cannot conclude until we are sure that the limit does exist. You understand where I'm coming from right now? So let's see how we can check that. So I'm going to say that the limit, I'll find the limit of as x approach 3 from the right hand side. So if you see this kind of a thing, that limit of x tends to 3 plus. So what this simply means is that you should find the limit as what? As x approach infinity from the right hand side. So, and what does that mean? That simply means that I'll have 1 divided by into brackets. From the right hand side, I'm going to be having something like 3.01. Are you getting it now? I can be having something like 3.1 because it's approaching it from the right hand side. Are you getting it now? So if that should be the case, I can just say the value of this is going to be 3.1 minus 3 all square. And obviously, when you say 3.1 minus 3, that's going to give us 0.1, right? 0.1 square. So if you say 0.1 square, That will give you 0.01. By the time you say 1 divided by is 0.01, this is very small. That means the answer will also be what? Infinity, but it's going to be positive infinity. So this is positive infinity, right? Then we check the second one for the limit as x tends to what? 3 from the left hand side. So when you see this, like when you see this particular sign, like limit of x tends to 3 and you have a negative sign at the top of the 3, what it simply means is that this value is something you are approaching from the left hand side. And when you see plus on it, it tells you it's approaching it from the right hand side. And you see how we tackle that. Now, when it's approaching it from the left hand side, it means we're going to be consider some values that are closer to 3 but less than 3. But if it is what? Approaching it from the right hand side, we are considering some value that are closer to 3 but greater than 3. Are you getting where I'm coming from? So here now, I want to be considering something like 2.99. Am I making sense? So this is 2.9 minus 3 r squared, right? So if I say 2.9 minus 3, that will give me negative 0.1. Of course, if I square it, it's become positive 0.01, which is like what we have initially. Obviously, that means this is also what? Tending to positive infinity. Now, we can say that the limit exists. You will say that the limit exists if the result that you have when the value of x from the, x is approaching 3 from the right hand side, when the value you have is equivalent to the value you have when x is approaching 3 from the left hand side, then you can say the limit does exist. And the limit that exists is going to be the value that you have, which is what? Positive infinity. Am I making sense? So some textbooks, when you look at some textbooks, they are going to agree with you that the limit does exist. I get it. Why some textbook will tell you that it is quite undefined. However, this is defined because the limit does exist and it tends to what? Positive infinity. So let's check for another one that we probably might have that the limit does not exist. And that will be limit as x tends to 0 of absolute value of x divided by x. So we want to check if this limit does exist. So guys, by now you should know how to check if a limit exists or not. And pause this video and give it a try and tell me if this limit does exist directly in the comment section before you continue watching the video. And let's see. So we first of all check if x is approaching 0 from the right hand side. That means we are going to have a value like, if it's approaching it from the right hand side, we're going to have a value like positive 0.1, right? So if I put that here, 0.1, absolute value of 0.1 is still 0.1 divided by 0.1. So this is going to give me positive 1, right? So let me say if it's approaching x, if x is approaching 0 from the negative side, that is from the left hand side, so that means this might probably be negative 0.1. I getting this now, divided by negative 0.1. So this is going to give me 0.1 and this one will still remain negative 0.1 and that will make this one to be negative 1. So if you look at it now, when x is approaching 0 from the right hand side, the result is 1. But when x is approaching 0 from the left hand side, the result is negative 1. Since this and this are not equal, that simply means that this limit does not exist. I hope you understand this now. The limit does not exist. And that's how to check if a limit exists or not. Or better still, you can plot the graph of this particular limit. When you plot the graph of this particular limit as x tends to 0, you'll probably have what we call jump discontinuity. When you have jump discontinuity as your graph, that shows that that limit does not exist. So if you look at it, when it's approaching it from the right hand side, you can see, you can see when it's approaching it from, you see where it's tending to. When it's approaching it from the left hand side and the right hand side. So you have what? Jump discontinuity. I hope you understand this now. So let's move on to looking at another way of evaluating limit. And this is called the H method for determining limits of a function. So when you talk about the H method of determining the limits of a function, it's just for you to what? To replace the value of x, or to replace x with a plus h. So where a is a constant, and you want to try as much as possible to simplify your expression until h is cancelled from the given expression. I know this is kind of abstract the way you are hearing me saying it. So let's look at an example on that. So the question says, evaluate the limits as x tends to 1 of x cubed minus 1 divided by x squared minus 1. You obviously know that if we are going to solve this question normally with the method we have described earlier, this is difference of 2 cubed and this is difference of 2 squared. So you know what to do, obviously. And if you don't know what to do, you can reverse the video back and see where we look at difference of 2 squared, difference of 2 cubed rather, and difference of 2 squared as well. Or you check the description part of this video to learn about the algebraic identity. So that will also help you a lot to know more than just difference of 2 cubed or difference of 2 squared. However, here we want to use what? The H method of determining limits of a function. So how do we go about that? What we do is the solution. We say the limit as x tends to 1 of x cubed minus 1 divided by x squared minus 1 is equal to the limit as h tends to 0 of, into bracket, remember x is tending to 1 here, right? So the a is going to become 1. So we have 1 plus h raised to power of what? 3, right? Minus 1 divided by 1 plus h raised to power of 2 minus 1. I hope you understand this now. So good. We now have that the limit as h tends to 0 of what? Of expand this bracket, you have 1 plus, yeah, we have 1 cube plus 3h, right? And plus h cube. Yeah, okay, so yeah, so that's what we have. Oh, but still, let me be sure of what I'm expanding. Right, so let's see, 1 plus h all square into 1 plus h minus 1 divided by 1 plus h all square minus 1. All right, so this one, by the time I expand this now, I'm going to be having 1 plus 2h plus h squared, then plus 1 plus h minus 1. All right, so divided by 1 plus 2h plus h squared minus 1. So this and this would cancel, and 2h plus h, that will give us 3h, right? And that's 3h plus h. So this is supposed to be h. Is that mistake somewhere? Okay, I'm not sure. I think we're on the right track. Let's check very well. When you expand this, you have 1 square plus 2h plus h. Well, yeah, plus h square, which is what we have here. Then this particular one here is 1 plus h. So when you use 1 to multiply all of these, oh, that's where the mistake comes from. So I've seen the mistake here. Okay, sorry please. So this is to multiply this now, 1 plus h minus 1, then divided by, this is going to be 1 plus 2h plus h squared minus 1. So I have to expand this like this so that you also get to understand this. So this is going to be limit as h tends to 0 of, open this bracket, 1 times 1, that's 1, right? So you have 1, and 1 times this, so obviously we're going to have this repeating itself again, and this is going to be plus h plus 2h squared, right? Am I making sense? Yeah. H, yeah, 2h squared, and plus h cube minus 1, then divided by 1 plus 2h plus h squared minus 1. So this and this goes, and we are going to be having this now to be 3h h squared. So I'm going to be having this, and this would also cancel, right? So we have that the limit as h tends to 0 of h cubed, then plus 2h squared plus 3h, right, divided by 2h plus h squared. So this is what I'm having currently now. Oh, this is supposed to be 3h squared, right? 3h squared. I supposed to just use, what's it called here? I supposed to just use this 3 here. I supposed to just use what's it called? Pascal's triangle. I'm supposed to use Pascal's triangle to just expand this instead of all of this stress. However, we can go on. You can go on. So I have this to be the limit as h tends to 0 of h cubed plus 3h squared plus 3h all over 2h plus h. Now, here, what we're going to do right now, h is common to everything here. So let's factorize out h. If I factorize out h here, I'm going to be having, okay, if I factorize out h here, I'm going to be having h squared plus 2h plus 3, right? Yeah, divided by h into brackets 2 plus 1. Am I right? Okay, yes. This is supposed to be square. Yeah. So this is h, and this is going to be square. All right. So this and this would cancel, obviously. Then if that should cancel, we have what? We have that the limit of h tends to 0 as h tends to 0 of h squared plus 2h plus 3 divided by 2 plus h. And this is quite simple. Now put the value of h, which is 0 plus 2 into bracket 0 plus 3 divided by 2 plus 0, right? So that shows that our result is going to be 3 all over 2. I hope you understand this h method now. And another type of method we want to talk about that we're supposed to talk about here is expansion method. So you can see the h method is as well simple. So let's look at the expansion method. And the expansion method is very great in you handling complex limits, especially when it has to do with transcendental functions. So I'm going to give you some series that you can actually derive them using Maclaurin series, but this video is not meant to cover Maclaurin series, which I'm going to be doing in future. So you can stay tuned to this channel. If you have not subscribed, you can do that right now, and don't forget to turn on the notification bell so that when I drop video, you get notified about it. So let's look at this series. Just master them, you can memorize them, and they are going to be very useful for you. So the first one is, if I have 1 plus x all to the power of n, this is the same thing as saying 1 plus nx plus into bracket n, then n minus 1 x squared rather, divided by 2 factorial plus n into n minus 1, then n into n minus 1 again, x cubed, divided by 3 factorial, plus, and so on like that. Are you getting where I'm coming from? But should, in case you have that, the value of x needs to be greater than 1. That is, the absolute value of x needs to be greater than 1 if you are going to use this particular series. That's the first condition. The second condition is that if n is positive, then this particular series has a limit. So don't worry. I know that statement is kind of complex. You don't really understand because we are not actually proving this, but just memorize this. It's going to do you a good. Okay, so the second one is the series of log. So if I have log of 1 plus x, this is the same thing as saying x minus x squared divided by 2 plus x cubed all over 3 minus x to the power of 4 all over 4 plus till infinity like that. You can see the sign is alternating. So you have to look into that. So absolute value of x must be greater than 1 if you want to use this particular function, because log of 1 is 0, and log of 0, I'm not sure if you want to try that, but it exists, though it's kind of complex for you to get. But we are not doing that now. So what about the series of e to the power of x? This is quite very important. 1 plus x squared divided by 2 factorial plus x cubed divided by 3 factorial plus ... like that. So you can as well find that of e to the power of negative x. So let me just put that down. E to the power of negative x, that will just be this is going to be 1, then this is going to be negative x, negative x, and this is going to be positive x squared over 2 factorial. This will be negative x cubed over 3 factorial, and so on like that. So the next one is going to be positive. That's if it is e to the power of negative x. So the next one, or the next series, is the fifth series. That's the sine of x. So the series of sine x is going to give you x minus x cubed all over 3 factorial plus x to the power of 5 all over 5 factorial minus x to the power of 7 all over 7 factorial, and so on like that till infinity. And the last series here is the cos series. So if you have cos of x, this is going to be 1 minus x squared all over 2 factorial and plus x to the power of 4 over 4 factorial minus x to the power of 6 over 6 factorial plus till infinity like that. I hope you understand this now. So when you want to use this method to solve limits, what you are going to simply do is to replace that number with its series. Are you getting it now? That is the function, like sine of x now replaces with its series in order for you to be able to use this particular method called expansion method of evaluating limits. So let's see example of such. Now, if I have that, the question here says show that the limit of sine of x all over x as x tends to 0 is equal to 1. So if you're asked to show that sine x over x as x tends to 0 is equal to 1, what this simply means is that sine of 0 over 0 is 1. Should in case you see somebody tell you that, the person is actually right. Are you getting where I'm coming from now? So, but you have to be in limit. Am I making sense? So how do I solve this? It's quite simple. All it just needs to do is to use the expansion method. So I'll say the limit as x tends to 0 of sine of x divided by x is equal to the limit as x tends to 0 of x minus x cubed divided by 3 factorial plus x to the power of 5 over 5 factorial, and so on like that, then divided by x. Are you seeing this now? So if this should be the case, then I can say the limit as x tends to 0 is x is common in this place, right? Factorize it out. Then we have x outside. Then this is going to be what? 1 minus x squared over 3 factorial plus x to the power of 4 over 5 factorial, and so on like that, divided by x. Have you seen this now? So this and this would cancel. So if x cancelled x, you have that this is the limit as x tends to 0 of 1 minus x squared all over 3 factorial plus x to the power of 4 over 5 factorial plus ... Are you seeing it now? So if I put 0 here, I will therefore have that the limit of sine of x over x as x tends to 0 is equal to 1, because all these, they are going to become what? 0. And that's how you can prove that the limit of sine x over s as x tends to 0 is equal to 1. I hope you understand this. Okay, so if you get this right now, the next thing we want to do right now is to see how we can find the limit of a trigonometry function. So, because that's another one. Like I told you, all of these functions are very important when it comes to calculus. They are the one that makes calculus quite interesting. So let's see. If the question here says, find the limit of sine 3x divided by 4x as x tends to 0. So, as a JAMBite, you really don't need to do anything here. Your answer is just 3/4. Yeah, just pick this 3 and pick this 4, and that's just your answer. You don't need to stress yourself as a JAMBite. However, if you would like to show your workings, then we can decide to do this. If you want to show workings, here is how to go about it. Just say the limit of x as x tends to 0, the limit of sine 3x all over 4x as x tends to 0. So what you want to be thinking of here, should in case the question is more complex than this, what you want to think of is how to come up with the limit of x tends to 0 of sine x over x that equal to 1. So this is what you are actually driving at. This is what you want to achieve. And if you can achieve this, then you are good to go. So how can I achieve that? I can pretty much achieve this by looking for a way of writing this denominator instead of 4x. I should look for a way of writing this denominator as 3x. Do you understand where I'm coming from now? I have to think of a way of writing this denominator as 3x. So how can I do that? I can do that by saying multiply both numerator and denominator by 3. So if I multiply both numerator and denominator by 3, I can simply rewrite these functions as the limit of sine of 3x divided by 3x multiplied by 3/4 as x tends to what? 0. You can see that it's still the same thing because 4 times 3 is the same thing as 3 times 4. Multiplication is commutative. So 4x times 3 is going to give us 12x. And at the same time, 3x times 4 will also give us what? Of course, you understand that right now. Now, the formula says, or the identity we want to use states that sine of x over x as x tends to 0 is equals to 1. So it's not that sine of 3x over 3x. That's not what it says, because x is what tends to 0 here. It's not 3x that tends to 0. So however, there's something we can do. We can just say let delta equal to 3x. So if delta equals to 3x as x tends to 0. So if I put 0 here, is delta going to be 0? Yes. If I put 0 here, delta will be 0. So I can now change these functions to become the limit of sine delta divided by delta as delta tends to what? 0. Do you understand what happened there now? I'm changing what? The input. But I have to come up with a value that still satisfies the limit. Do you understand that now? That's the essence of what I did here. As delta is now equals to 3x, we want to express this what? This entire function in terms of delta. So we know that x is what? Tending to 0. So if I put 0 here, what will be the value of delta? So the value of delta is also what? 0. Multiplied by 3/4. So remember, the limit of sine 0 over 0 is 1. For that reason, 1 times 3/4 is simply 3/4. I hope you understand this, guys. Alright, so let's look at another example if you have gotten this. So another one we want to look at now is that evaluate the sine of 7x divided by 5x. Limits supposed to be here. Evaluate the limit of sine 7x divided by 5x as x tends to what? 0. Now, as a JAMBite, obviously, pause the video and just tell me the answer directly without even solving. Thank you. Correct. That's 7/5. How do we get 7/5? Obviously, we'll do the same thing that we did earlier. So we try to write this, the limit, as x tends to 0 of 7 sine 7x over 5x. So we'll multiply both numerator and denominator by 7. Am I right? So if we do that, we are going to have this to be the limit as x tends to 0 of sine 7x divided by what? Divided by 7x times 7 over 5. Have you seen that now? So let delta equal to 7x. So if delta equals to 7x, as x does what? As x tends to 0. So delta is also 0. So we can now have this as the limit of delta tends to 0 of sine delta divided by delta times 7 over 5. And this will just give us 1 times 7 over 5, which is 7 over 5. Okay, so I hope you get this now. But obviously, it's not only sine that we have when we talk about trigonometric functions, right? So let's try. What if I have that evaluate, if the question says evaluate the limit of tan 5x divided by 3x as x tends to 0. All right, guys. So obviously, this is the same thing as sine function. So the same thing we did to sine is the same thing we are going to do to this. So that will be 5x. Sorry, your result is just going to be 5 over 3. So if you are a JAMBite, you don't need to waste time doing this. But is that the same thing with cos? No. Cos does not obey this. Do you understand where I'm coming from right now? So let's see now. So if I have this, how do I solve this if I want to solve it normally? So I'm going to say the limit as x tends to 0 of, you remember, tangent of theta is the same thing as saying sine theta over cos theta. So this is going to be sine of 5x divided by cos of 5x divided by 3x. I hope you understand this now. So I'm rewriting tan in terms of sine and cos. So if I do this, how will I go further to create what I want to do? I think for me to make this kind of very easy for you, okay, it's not, there's no problem. It's still very easy. So let me just rewrite this neatly. So this is going to be the limit of sine of 5x divided by cos of 5x multiplied by 1 over 3x. I hope you understand this now. All right. So if you understand this, the next thing I want to do now is to make what? Is to get what we usually get, that is sine of 5x over 5x. That's what I want to achieve now. So how do I achieve that? So very simple. I will just say the limit as x tends to 0 of sine of 5x divided by cos of 5x multiply by 1 over 3x, then multiply by this, which is going to be 5 all over 5. Have you seen that now? And this implies the limit as x tends to 0 of sine 5x divided by 5x multiply by what? 1 over 3 cos 5x. Okay, no, I'm trying to manage space there. So let me take this back a bit. So this is 0. So this is going to be sine 5x divided by, now watch something here. You know, this is going to be 3x times 5, right? So, and then times cos 5x. So, but I want to write it as what? Cos 3 times cos 5x, then times 5x. Do you understand that now? So that's what I'm to do. So I'm going to put 5x here, multiply by 1 over 3, multiply by 1 over cos 5x. I hope you still get this, right? Okay, so we're running out of space, so let me just adjust this upward a bit. Good. So this question will now become the limit as x tends to 0 of sine 5x divided by 5x multiplied by 1 divided by 3 into brackets cos 5x. I hope you get this now. So let's delta equal to 5x as x tends to what? 0. So if x tends to 0, that simply means that we are going to be having delta to also equals to 0. So this function will now become the limit as x tends to 0. Or before I do that, let me just do this. Let me make it better. So mathematically, don't let me do what is not mathematically correct. So do this. Limit as x tends to 0 of, because if you remember the properties of limit is that the product of a limit, I getting it now, is equals to what? Limit of a product. Do you understand that now? So this is this divided by 5x multiplied by the limit as x tends to 0 of 1 over 3 into bracket cos 5x. Yeah, so if I have this right here, I can say from here now, I can say let delta equal to 5x as s tends to what? 0. Am I right? So if this is what I have now, I can then say that this is going to be the limit of delta tends to 0 of sine of delta divided by delta multiplied by the limit as x tends to 0 of 1 over 3 cos 5x. So let's put in the value. So if you put the value here, this one is going to become 1 multiplied by, this is going to be 1 divided by 3 into brackets. I think we are missing something on the road. Something is missing somewhere. It's not supposed to be 1. There's a number missing at the top. Okay. Yeah, so we are missing this 5 here. The 5 at the top here is missing. So I just checked that now. So let's put this one to be 5. So this is supposed to be 5. This is supposed to be 5, not 1. So this is supposed to be 5, not 1. Yeah. Okay. So I hope you get that now. Thank you. I know some people already observed that, and yeah. So let's go on now. So this will be 5 all over cos 0. So cos 0 is what? 1. So we have 1 times 5 all over 3 times 1. That means the limit of the tangent of 5x divided by 3x as x tends to what? 0 is equal to 5 over 3. And that's how to evaluate the limits of a trigonometry function. I hope you understand this now. Alright, so I'm going to I would like to put a stop here because of time. The video is getting too long, and I just want to believe that you now understand this. But before I call it a day here, let's wrap it up by looking at the limits of a function as x approach infinity. So let's see. Evaluate the limit of 8x plus 2 divided by 2x minus 5 as x approach infinity. Now, whenever you are given a functions that approach infinity like this, the best way to tackle this is obviously looking at this. I just know that the answer here is going to be 4. And how do I know that? Is that since the power of x at the denominator, the highest power of x at the denominator is the same thing as the highest power of x at the numerator, that means the answer to this limit is going to be the fraction of their coefficients. That is, this is their coefficient. The coefficient of x at the numerator is 8, and coefficient of x at the denominator is 2. So your result is just going to be what? 4. However, that trick is for JAMB. And I'm going to show more of it. Just stick to this channel. Now, let me solve this normally. How do I solve this? For you to solve this, all you just need to do is to divide both numerator and denominator by the highest power of the unknown in the denominator. So the highest power of the unknown in the denominator is x raised to power 1, right? So I'll just write this as the limit the limit of 8x plus 2 divided by 2x minus 5 as x tends to infinity. So that means I have to multiply both numerator and denominator by 1 over x. So if I do that, I will have that the limit as x tends to infinity, 1 over x times 8x, that will give us 8, plus 2 over x. Am I right? Then divided by 2 minus 5 over x. Now, you already know that when a number tends to infinity, if the denominator of a number is infinity, your result is going to be 0, because when the denominator of a number is large, the result of that fraction is going to be small. So, and when the denominator of a fraction is small, the result of that fraction is going to be big. So, if the denominator of a fraction is so big that is infinity, that means the answer is going to be so small to the point that it will be negligible, right? So, that's why we said it's equals to what? 0. So, if this one is 0, we have 8 plus 0 all over 2 plus 0, and that will be 8 over 2, and that gives us 4. So let's look at one more example, and we can call it a day. So just stick to the channel, because I'll be solving more questions on this as time goes on, so in case you want to learn more about questions on that limit. So this is going to be 9x squared minus 3x divided by 5x minus 3x squared plus 2. So if I have this right now, my result is just minus 3. Remember the trick? I just gave you this so that I can validate the trick I showed you. So this value will be what? 9 divided by minus 3. Why? Because the power of the numerator and denominator is the same thing. So, but let's solve it and see what the result is going to be. So this is going to be limits as x tends to infinity of 9x squared minus 3x divided by 5x minus 3x squared plus 2. So what's the highest power in the denominator? That's x squared. So multiply both numerator and denominator by 1 over x squared. So that will make this one become the limit as x tends to infinity of 9 minus 3 all over x divided by 5 over x minus 3 plus 2 over x squared. So at infinity, you have this to be 9 all over minus 3, which is the same thing as negative 3. So thank you so much for watching to this point. I really appreciate you guys. So you can try these following examples, and you can stick to the channel to see if I'll come back to drop your solution if you have gotten it. So evaluate the limit of e to the power of x minus e to the power of negative x divided by x as x tends to 0. So try this, and you can as well try this. Evaluate the limit of let's say evaluate the limit of x to the power of x as x tends to infinity. Try this guys. Evaluate the limit of x squared, not equal to, evaluate the limit of x squared minus 1 divided by x squared minus 9 divided by x minus 3 as x approach what? So the limit as x approach 3. Yeah. So I have more to give you guys. Okay, try this. What will be the result of this? The limit of tan x all over s as x tends to 0. So what will be the result of that? And you can as well try this. All these are just exercise. The limit, evaluate the limit of sine ax divided by sine bx as x tends to 0. Okay, so where b is not 0, note b is not 0. Okay, so you can as well try this. Okay, this one is just proof. Show that the limit of x to the power of n minus a to the power of n divided by x minus a is equal to n multiplied by a to the power of this, yeah, as x tends to 0. Okay, I would like to put a stop here so that you can have time to practice more from your part. Just stick to the channel, as I'm going to be dropping more questions on that limit before we go into differential calculus. Thank you guys. If you're yet to subscribe to this channel, don't forget to do that. Please do that right away and share this video with your friends. See you on the next one.